This is R.D. Sharma Solution Class 12 Chapter 19. We are taking exercise 19.21 Indefinite Integrals. Now this question seems to be the question we have done already, but the benefit is if you watch this question very carefully, you will see that the numerator is already the differentiation of the denominator. What I am trying to suggest is if you take this denominator, which is t equals to 3x square minus 5x plus 1, and we differentiate it dt by dx, it will be 6x minus 5, which is actually the numerator only. So this dt will become 6x minus 5 into dx, which is actually the numerator. So this integration will be formed like this. The numerator will call it as dt, and since we have taken the 3x square minus 5x plus 1 as t under root t, and we know the direct integration is 2 under root t plus constant of integration. What is t? T was 3x square minus 5x plus 1, which we are going to put inside the root. So this one plus constant of integration is your result. So this is very straightforward question and you don't have to do much about it. Now this question you need to watch very carefully. We have done already a question like this. And we'll be doing this, and those questions which will be following having this negative x square under root wherever it is. So we are going to skip the question which are coming after this. So you need to be very careful. I'm going to solve it in the entirety. The only thing is why this question needs proper consideration is we have a negative x square. Quadratic is negative x square. So what we do generally is 3x plus 1, the numerator is to be represented in the denominator form, that is a into d by dx of 5 minus 2x minus x square plus capital B, that is capital A, and differentiation of this will be 5 will be 0, negative 2 minus 2x plus this B, 3x plus 1 it is. So we will try to equate it with these similar terms. So let's multiply this inside, minus 2a minus 2ax plus b. So let's combine this minus 2a plus b and then minus 2ax and equate it with the corresponding similar terms. So negative 2ax can be equated to 3x and negative 2a plus b will be equated to 1. From the first equation we got a is equal to negative 3 by 2, and if you put this a equals to negative 3 by 2 here, negative 2 into negative 3 by 2 plus b is equal to 1. So this gets cancelled. You have a 1 on the right and this will be negative, negative gets cancelled, 3 on the left. So 1 minus 3 will be negative 2. So this 1 minus 3 will give us negative 2. So we have this a and b now. So this equation is actually the numerator. We have just formed it in a way so that we can separate two terms out and then we can deal them in a separate way, that is divide and conquer kind of approach we have followed. So this integration I will be divided into 2. A is negative 3 by 2. This is negative 2 minus negative 2x. So minus 2 minus 2x divided by the denominator remains the same. It is 5 minus 2x minus x squared. And for the other term we have b, which is equal to negative 2. So let's write negative 2 outside the integration. And then whatever is inside, it's just dx inside. So dx divided by under root 5 minus 2x minus x square. So this is 5 minus 2x minus x square. So this will be called as I1, this will be called as I2. And we will just approach them in a separate way and then combine them together to find the I. Now this I1, we have already done 5 minus 2x minus x square differentiation and it was negative 2 minus negative 2x. So I1 will be, just take this t equals to 5 minus 2x minus x square. I'm writing it as t. So t is 5 minus 2x minus x square. dt by dx will give you what? We have already done that, so you don't have to do it again. It's just negative 2 minus 2x. So dt will be equal to this term which is on the right and which is eventually the numerator which is. So this dt is numerator and you have taken this as t, so it will be under root t in the denominator. Negative 3 by 2 here. So integration of this you already know, negative 3 by 2 under root t, integration is 2 under root t, 2 gets cancelled. So you have minus 3 and under root t was of course 5 minus 2x minus x squared, and plus constant of integration, just call it as c1, because there will be one constant coming from I2 also, and we'll combine them to call it as a single constant. What is I2? Now we need to make this 5 minus 2x minus x square as a perfect square. First thing first is we cannot go ahead until we have a negative x square. So you have to take a negative outside first. So once you take this negative outside, it will be x square plus 2x minus 5. What is the coefficient of x2? 2 divided by 1 is 1. 2 divided by 2, this 2 by 2 is 1. 1 square is 1. So add 1 and subtract 1. So a plus b whole square formula, x square plus 2x plus 1. Whatever is remaining, minus 5 minus 6. So you need to make it as a perfect square. So make it as under root 6 whole square. So negative is already there. So once you multiply this negative inside, these two terms will get switched. Root 6 will come first and x plus 1 whole square will come after that. So we already have a 2 outside, and I told you that this is a dx by under root. Now I'm writing this as under root 6 minus under root 6 square minus x plus 1 whole square. So under root 6 whole square minus x plus 1 whole square. Now you don't have to do anything because it's simply dx by a square minus x square under root, and we know the direct result of this standard result. It's simply sine inverse x by a. 2 is already there, just write sine inverse. What is x here? X plus 1. What is a here? Root 6. So 2 sine inverse x plus 1 by root 6 is the second term. Call the constant as c2. So this is the first result, I1. This is the second result, which is I2. Now let's combine these two. And I told you that we will combine these two. We have a negative sign in between. So actually we are subtracting these two. So minus 3, 5 minus 2x minus x square. C1 and C2 will combine and call it as a capital C. What is the second term? It's a negative in between. And 2 sine inverse x plus 1 divided by under root 6 plus a constant of integration, which is capital C. This is your final result. So this is how you are going to go about it. We have already done a question like this. You have a basic idea. We have done it again. So this things remain same. Only the point of deliberation is negative x square. All right. Now most of the people, they comment that the important question you leave. My point is we have already done 2 or 3 questions like that. So it's not advisable to do the question again and again because you know the concept now. Okay. I respect the feeling behind that comment, but the only thing is that we have many questions like this in r.d.sharma repeatedly. So it's better to understand 1 or 2 properly so that you can do it by yourself. Of course, I'm showing you the reference which will be beneficial for you if at all you fall into some trouble. Now again, same thing here. X plus 1 by x square plus 2x minus 1. Initially, we have done question like this. So I'm just showing you the reference. If you have any problem or any trouble, just let me know in the comment and we can solve this again. So this you can do. I hope I have full faith on you. Now this question is somewhat different. And the next question also will be on this same line. So we have x plus 2, denominator we have x square minus 1. It's essentially a quadratic equation only without an x term. So if you differentiate it, you will get a 2x. So we already have an x in the numerator. Constant, we can just separate them out. So this I will be written in the form of I1 plus I2. There is integration of x divided by under root x square minus 1. This is the first term. The second term will be 2 divided by under root x square minus 1. And we are just separating them out. We have done nothing up till now. I'm taking first one as I1. Now just take this x square minus 1 as t. When you take this, dt by dx will be equal to 2x, twice of x. Now you need a x in the numerator, x dx. So dt by 2 can be written as x dx. We have brought 2 in the denominator, dx we have taken to the numerator on the right hand side. So already got the numerator now, which is dt by 2. This will be dt by 2, half can be taken outside. Denominator under root x square minus 1 was taken as t, so under root t. This integration we already know. I told you in the beginning of this exercise and various other time. It's twice under root t. 2 gets cancelled, you get only under root t. T is x square minus 1, so under root x square minus 1 plus constant of integration c1. This is your I1. How about I2? I2 is even simpler than the I1, because if you take these two outside, this is a direct result. Is simply x square minus 1 square. So we have integration of dx by under root x square minus a square, and this you know log x plus under root x square minus 1. X square minus 1 square is x square minus 1 plus constant of integration c2. 2 is already there. Now you can just combine these two. I equals to I1 plus I2. We have I1, we have I2, just add them and that will be the final result. So I am combining these two, under root x square minus 1, and this is twice log modulus of x plus under root x square minus 1, and I am combining the c1 and c2 and calling it as a capital C. So let's take it as a capital C. That's your final result. Now just let me know, if I write this x plus 2 as x minus 1, will you be able to do this? Same thing, only numerator changes. I hope you got this idea. These questions in the similar way will do this x minus 1 also. So this is the reference for this question. Those who want to do by themselves, they can just do it. And the same question which we just talked about, this is, I told you this is a different kind of question. So we have a two question almost similar. This is the second question I was talking about. X minus 1 divided by under root x square plus 1, which is essentially similar to the previous one, which is the question number 8. So I'm giving you a reference. If you understood the previous one, you will be able to do it. In the similar fashion, you can do this one also as we have done in the previous question. Now this question, x square plus x plus 1, we have already done questions like this. Let's try and see. This is not a special question. We have already done a question like this, and I explained you in the entirety. But for the sake of completion, I would like to do this because these questions will be coming again and again. So you have to have a very clear idea. X will be represented as a into d by dx of x square plus x plus 1 plus constant of integration which is b. This gives you a 2x plus 1 plus b. This will be 2ax plus a plus b, and this is equivalent to x. Now you can equate these similar terms. So 2ax will be equal to x and a plus b is equal to 0. From here you will get a as half, and when you put it here, that is half plus b equals to 0, b will give you negative half. So b will be equal to minus half. So this equation was made only for x in terms of certain constant and the numerator term, differentiation of the denominator. So we'll separate these two terms out and try to make it as two terms, divide and conquer approach. So half, because a is half, 2x plus 1 divided by under root x square plus x plus 1. What is b? It's minus half. This will give you, b will be dx, and denominator remains the same, under root x square plus x plus 1. This is 2x plus 1 dx. We'll call it as I1, this is as I2. I1 will do it since we know that 2x plus 1 is the differentiation of x square plus x plus 1. So let's take t as x square plus x plus 1. dt by dx will be equal to 2x plus 1. So dt will be equal to 2x plus 1 into dx. So this is the numerator. Just write it as dt. Half is outside. So dt divided by under root. What is inside under root? It's t. Half is already there. And integration of dt by under root t is twice of under root t. Plus constant of integration. 2 gets cancelled. You have under root t. T is simply x square plus x plus 1 plus constant of integration. This is your c1. Now coming to I2. I2 is what? You have to make it as a perfect square. The coefficient of x is 1 divided by 2, so it will be half. Add half square and subtract half square. So this I am adding and subtracting. It won't affect x square plus x plus 1, but it will make the perfect square. So a square plus b square plus 2ab, x plus half whole square is first term 1 minus half square. 1 minus 1 by 4, that is 4 minus 1 by 4, that is 3 by 4, which is root 3 by 2 whole square. So minus root 3, it will be plus, sorry, root 3 by 2 whole square. So this integration will be formed like this. Dx, we have a negative half, so you just write half. dx divided by under root x plus half whole square plus root 3 by 2 whole square. And this is simply integration of dx divided by under root x square plus a square. You already know what to do with this. We have a direct result of this. I'm going to write the direct result right now. Half log, what is x? X plus half. So you can just write x plus half here inside the modulus, plus under root whatever is there. From where this x plus half whole square plus root 3 by 2 whole square has come? It has come eventually from x square plus x plus 1 only. You write x square plus x plus 1 and finish the modulus sign. C1 plus C2, so just call C2. This is I2. Now I1 minus I2, because there is a negative sign in between. So just write this I1 minus I2, which is actually the final result I. So let me write the direct answer. The I1 is under root x square plus x plus 1 plus constant of multiplication. I am going to combine the C1 and C2 and call it as a C. Now this will be second one, I2 will be half log of modulus x plus half plus under root x square plus x plus 2 modulus we will n plus constant of integration. Now this is your final result. Now let me show you the reference also. This is how you're going to go about it if you're solving by yourself or if you're writing somewhere. Now this question already we have done, but we'll see what we need to do in the next discussion. Till then, thank you so much and have a good one.